Okay, so today we are going to be solving many logarithms that include, as you can see here, just solving simple ones with numbers, or we have to solve for y or otherwise b or other terms. And then we move on to more of the equation side, such as like log, for example, the first one, log 3x minus 2 equals 2, and we have to kind of solve that and solve for x. So I'm going to start off and give some tips. So whenever we see a log, I like to say it's a fancier way of writing it in an exponential form. So log 5 of 25, so ready, we have to listen here because this is really important. Log 5 of 25 is actually, is actually 5 to the y. So we take this side and we place it as an exponent on whatever the log base is, equals 25. So as a sort of an arrow here, so the right side of the equation, or whatever side has the one term, if you're dealing with these types of equations, we drop it on the 5, on the log base here, and then equals to whatever the log is focusing on, so the 25. So, for example, in this equation, 5 to the y is equal to 25, and we know that is 2 because 5 squared is equal to 25. So we can use this, and we can do y equals to 2. So it gets a little bit tricky when you're just starting out, but now next one, look, we're going to do the same strategy. We take this side, the right-hand side, and we're going to plop it on the 9. So this could even be an x. The right-hand side could be an x. Let me just write that. It could be an x. And actually, technically, it's not solved for a while. I'll just remove this. And guess what? Same thing. 9 to the x, or this other side, must equal to 81, which is what the log is focusing on. So 9 to the x equals 81, and actually it's similar to last time. We get 2 because 9 squared is equal to 81. Or if you want to do it completely thoroughly, you can square root each side to x. So you can go here, square root to x, square root to x. The exponent of x and the square root of x cancels out, so this is just 9. And so 9 equals what square root of 81? And that's 2. So x is going to be equal to 2. So as you can see, it's a common theme here. Now, this one, it's a little bit trickier. I'm going to skip to 4 for now because then we'll get more practice. So these are this 1 and 2 are a little bit easier because they're kind of straight numbers. But rather 4 and 3 are a little bit difficult. And 5 is a different level, so we'll do that when we get there. So let's do 4 for now. So again, even though this might look intimidating, what we want to do is, this is log 4 of 8, I can just put this in parentheses, is, if we just have the log, we can just set it equal to x. Let's set it equal to x. Okay, so this equation, remember, we're going to plop the x on the 4, right? So it's going to be 4 to the power of x, right, because we're plopping it on, equals 8, whatever the log focuses on. So now this is not clear because 8 is not a power of 4, but what we can do is we can simplify this in terms of exponents. So so we notice that this 8 and this 4, we have to make connections. They have common powers, not in and of themselves, but they can both be written as a power of 2. So that's basically one big rule. So a big rule here. If we're going to find the similar or common power. So you can put that into whatever you're writing on, or just keep that. in mind. So this is the big rule we are working with. Sorry, this is getting a little bit messy. Let me try to just, let me copy this and shrink it. Oh, right there. Okay, so now it's kind of funny because it's a big rule, but it's small, but, okay, so that big rule is we're going to find, likewise in this case, these are both powers of 2, and that's the common power. So if we want to do that, we're going to degrade them to powers of 2. So let me just section this off. So 4x could be written as 2 to the power of 2 all to the power of x, right? And then 8 can be written as 2 to the power of 3. You know what? Wait. Let me just get some more space over here. Okay. So this, now we want to distribute, make this the simplest terms as possible. It's like the previous video with my trig identities. We kind of want to make it as simple as possible. So we get 2 to the power of 2x equals 2 to the third power. Let me just remove this, right? Now, what we can do is if exponents have the same base, then if they have the same base, we can just set the equation to this. And so just focus on the exponents, or any exponents on the top, if the bases are equal. So let's say there was 3 to the power of 2x equals 3 to the power of 3. You don't want to multiply that or find the exact value of both of them, or maybe just the 3 to the power of 3, because then you would have to convert them back to the common power. But all we want to do is set the exponents equal to each other because it's the same base. Okay. Basically, so then we set this, we bring both of the exponents, and so we get 2x equals to 3, right? And this is simple. All we have to do is divide by 2, and we get x equals 3 over 2. And that is the final answer for log 4 of 8 equals, well, I guess x. It's just log 4 of 8. Okay. So that is the answer for this. I'm actually gonna, oh, okay, that was helpful. I should have just done that in the first place. So let's move this over here. Oh, let's just go here. I'll just rewrite the 3. So now we have this here. Okay, why is this not, okay, shoot. Okay, so now this is a little more complicated. And it basically just asks us to simplify, because we can't really find the exact value for this. So what we want to do is similar to trig identities. These have many rules. So I'm just going to write, and apart from the big rule, they're mathematical rules, basically. And so what we want to do is we want to apply all these rules on the equation. So one rule of this equation, let me just get the 5 out because it's kind of, okay. One rule of this equation is that, I'll just write it here. So another rule, actually we have a lot more space than I thought. So I'll just write it up here. This rule is that log of a to the power of b is equal to log b over log a. And they have to have a similar base. So, or they have similar base of logarithm. So they both, in this case, they're both c. And so that is a logarithmic rule. And that we can apply this to this. So we can apply this rule to here. And likewise, there's other ones where you can apply more rules. Okay, so we get b, we rewrite this, remember b, and then we use this rule. So this is log b of 3. Oh wait, actually, yes, I think, was this the original equation? I think so. So we get log b of 3. And actually, I think this equation was actually log 3 of b. Okay. So now we get b, and then we apply this rule. So b is in front. So whatever the log is focusing on, that's the top one. So we get b log of, or so in this case, if we ever, in this case, it's going to be log of b, so log 3 of b over log 3. Okay. So actually, no, sorry, my bad. Whenever this happens, we're just going to create a separate one, and usually it's to log 10. So basically another rule is that usually when you have just, let's say, log of x, it's going to be equal to log 10 of x. It's basically, that's usually what the common log base is if you don't have a specific log base. So applying the rule now, to get log 10 of b over log 10 of 3. So this isn't really simple it isn't like an easy equation that we can find out, but I'm going to slide this quick caret here. But now we know that this is like the arrangement of the logs. So now what we can do is we can basically, whenever we have another rule, whenever we have a number to a fractional exponent, we take the bottom or the denominator and that's going to be the square root value. So, and then the numerator is the power to which the original number is put. So let's say we have, instead of that, let's say we have 3 over 5 to the 2. We get the square root of 2, square root of 3 to the power of 5. And so you can work this out, but that is how you do it. So that is a quick lesson. And so applying this here, we get that we're going to put log 3 as the, basically what we're square rooting it by, or not square root, but what we're putting this as, and log 3, and then we're going to, and remember, it's 10, and then we're going to do and then we're going to put b in here, and then we're going to do log 10 of b. So, and that's basically put in that power. So this is how, like, the farthest we can simplify it to. And I just wanted to show you how you can, as in trigonometry, we show this is equal to this. So we just showed that this is equal to this. It actually, this side looks a little bit more complicated, but that's that's how we can just take this exponent and log down. So now I'm actually going to quickly show you what would happen if we just plugged in 3 for b, right? So, and I'll show you that it works out. So let's just use this right here, and let's let's just put it off here. So if b equals 3, then we get 3 to log 3 of b. Okay? Alright, sorry, not b, sorry. 3. So remember, we can actually put this into a mini equation up top. So log 3 of 3 is 3 to, remember we plop it down, it's going to be log of x. So log, sorry. So what we're going to do is we're just going to assume that this side is x. This doesn't really make sense as a whole, but let's just focus on this. So we get, plop this down on the 3. We get 3 to the x equals 3. Obviously, 3 to the 1 is equal to 3 to the 1, so the x is going to be equal to 1. And so if x is equal to 1, then log 3 of 3 is going to be equal to 1, and that's our final answer, is 3. So that is how we prove this using this particular rule. And yeah, that's how we do it. So let's just move down here. I think I'm going to have to, unfortunately, delete this. I'll keep the rules, but I have to focus on this. So these are the rules. You put them down in your notes. I'll highlight them with pink. So these are the rules. And then let's just put another rule. Wait. And I'm going to do that 3 to the power of 1 over 2 is equal to the square root of 3 to the power of 1. So, okay. That is another rule. We're just going to put it in the box. Okay, perfect. So now we've done all that we can, or not, maybe not all that we can, but we've done a lot to prove certain logarithms and their numerical value.